at the end of the result page. That means that the last result on the page is, well, maybe receives a little bit more hits than the result before. And this is the plot of the first 10 ranks. So basically meaning that this is the first result page. And this is not log scaled, so that you can see that actually rank 1 receives by distinct the most hits, while actually, well, the click-through rate triples. So this has certain implications for the so-called search engine optimization. Of course, everybody is keen on getting rank 1, but now it's obvious why, because getting from rank 3 to rank 1 not even doubles your click-through, but getting from rank 2 to rank 1 triples your click-through rate. So it's clear why everybody is keen on rank 1. And, well, you can also state that holding a result with rank modulo number of results per page equally to 0 or to 1, which means that you have the first result on the page or that you have the last result on the page, is even slightly better than holding a higher rank. Well, what else is interesting? If you hold the last possible result, which means in our case rank 500, so it is the last result on the last page, this actually receives a lot of hits, more hits than any rank below 270. So, well, if you can't go for rank 1, go for rank 500. Okay, now we'll go into the actual analysis of the query content itself. We'll look at the distribution of the queries. We'll look at, well, the topic. We will look at the statistical of the pie chart of the topic categories, and, well, maybe we can differ. Maybe we can find some geographical locality in the queries. Okay. To give you a first impression, this is the list of the top-rated queries by frequency. Well, okay. Google, eBay, Yahoo, no surprise, because these are very popular services. This one is the anti-query. What is really funny for me is that people are looking for the term internet. Well, I was not sure why this happens, because maybe they are searching the internet, they are not aware of the fact that they are actually in the internet. I'm not sure. Well, maybe this is due to the AOL users, but what else is interesting? People are looking for URLs, for full URLs. So the question is, why are they searching for URLs they actually know? Why do they type them in the search bar instead of typing them in the address bar? So, well, there's a number of possible explanations. Of course, you might want to use the search engine cache, or you might want to use the translate button, or you might want to find related sites. Well, but I don't believe that, well, you don't want to translate Google or something like that. Maybe it's due to the fact that these are beginners and they are not aware of the difference between the search bar and the address bar. They use it maybe for the same purpose. Okay. This is a plot where I plotted the frequency of the query by the actual query rank. And both scales are log scaled. And if that results into a straight line, we call that Zipf's law. Well, so search query meets Zipf's law, which is basically a very popular power law in the computational linguistics. And it basically means that the query rank divided through the frequency of the query is more or less a constant. It's had certain implications for, well, maybe search engine caching or the search itself, but we don't want to go into detail with this. What else is interesting? The average query length by terms is only 2.5 terms, which is actually more than I expected, but it is too less to find appropriate results. So if you only enter 2 terms and you hope to find the right site, well, in some cases it might be if you look for Google or what, but in other cases it might not be appropriate. What is important is that the character set of the queries is some kind of messed up by AOL. They removed slashes, they removed columns, the percent sign, and the quotation marks, and this has some implications for our later analysis, so just keep that in mind. Okay, we're not only interested in the frequency of a single query, we are interested in the, well, frequency distribution of topics. So the question is, how can I detect the topic of a query? There are a number of possible solutions. I have chosen a very simple one, which I call the DMOS solution. If you want to determine the topic of a query, you look up the URL in which the user clicked in the DMOS directory, and you take the URL in which, you take the topic category of the URL in the DMOS directory as topic for the search query. Well, and then you count the matches for each topic category, and this is the result. Of course, regional queries are some kind of overrepresented. You will see later on that these are regional queries for North America. Then we have computers, shopping, business. What is some kind of surprising that the topic category adult entertainment has only 1.5%, which seems pretty low for me. But this is, well, you can imagine why. Because maybe not every porn URL is listed in the DMOS directory. So what are the pros and cons of this solution? Well, of course, the pros are this is a very quick solution. It delivers comparable results. But the contra is that you are bound to the topic categories of DMOS. So there are much more sophisticated approaches possible. Well, you can think of unsupervised clustering of search queries where you cluster the terms by some collocation measure and you get a much more natural motivation for topic categories. But then you run into other problems, and so I did not show that here. Well, okay, again, queries with original character are overrepresented. What else can we do? We can differ between local and global queries. Local queries are queries containing a reference to some kind of local aspect, so maybe city names, county names, state names, country names. So, and what I did is basically plotting the regional aspects, so localized queries, in this case by state. The darker the color, the more this region is represented in the queries. So the top-rated areas are, well, Florida, Texas, New York, California. But what is even more interesting, that if you plot this on the country level, well, you could even see the origin of the data. Okay, we did that, we knew that before, but if we wouldn't, we could notice it here. So queries with relation to the region United States are overrepresented. A bit Mexico, a bit Canada. Well, can you see it? No, actually not so perfect. A bit India, a bit China, and a bit Russia. But sorry, folks, Germany is, well, quite underrepresented. So this is one thing you could do. Let me introduce you to the area of search trend mining. So questions might appear, do queries change over time, or are they equally distributed? Do queries correlate with current events of times? What queries do change most? And so you have to develop a methodology for investigating in those areas. Well, you basically do a time slicing on the data sets, where you split the data set into k equally sized partitions, and then identify the queries which with the largest growth rate over 2 consecutive slices. So these are the first results. What I did is with a k of 92, which basically means that each slice is a day. And these are the top rated queries to this interestingness measure, which is basically the difference between the frequency in the consecutive slices. The results are quite suspicious because there are many top rated queries in the list, and the slice where the significant growth takes place is sometimes the same. So I investigated in this, I plotted the top rated queries, and well, usually they should not change much, but this is the problem. This is the sudden decline which you saw before and which disturbs our search trend mining algorithm. So because this is a very sudden increase. So the only solution that I saw is manual filtering the suspicious slices and the top rated queries and ORLs. But if you do that, you get really some lists of interesting queries which do change significantly over time. We will look onto that now. This is the area of entertainment queries where, well, people are looking for maybe the Country Music Awards, Deal or No Deal, American Idol, or the Oscar winners. And, well, what you see is the red line is the Country Music Awards, and the increase of the query frequency strongly, tightly correlates with the broadcast of the Country Music Awards in TV. So the same for the Academy Awards here. And well, and you can even see some cyclic TV shows, Deal or No Deal, which is some kind of quiz show, and well, American Idol, which is the equivalent to the German pop stars show, I think. Well, you can see some kind of weekly broadcasting cycle. So at least these queries correlate with the actual event in the real world. We can do that for all other kinds of people in the list. This example is for person names, where you can find Whitney Houston is very often looked for during, well, she had a period where she was fighting her drug addiction, and this was all over the media. This is Laura Welch Bush, which visited the American troops on the 1st of May in Afghanistan, I think. So this is this sudden increase. And you could, well, develop that further. There are even some correlation with public holidays. People are searching for, well, Easter, of course, on Easter Sunday. Well, this has certain implications. You can optimize maybe your Google AdWords campaign to that or whatever. This one is Ash Wednesday, the green line. Here's the Memorial Day. And, well, where is Mother's Day? People are actually looking for Mother Day poems and Mother Day gifts just on Mother Day. Okay, this is the summary for search trend mining.